This question is for 3 marks, so typically this one can just be factorized into 2 brackets, but you can use the quadratic formula if you wanted to. But the 2 brackets would be x plus 4, and x minus 3. Because, yeah, if you had to multiply that out, you would end up getting exactly this over here. At this step, we can say that x plus 4 is equal to 0, or x minus 3 is equal to 0. Therefore, x is minus 4, or x is equal to 3. With a square root equation, you want to get the square root by itself. So like you want to get it on one side, but that's already been done for us. Can you see that? But if the question had like something like this, for example, then you would first take this minus x and you would first put it on the other side. But that part has all been done already. So our next step now is to square both sides. Okay, so we square both sides. So what happens is that this 2 will cancel out the square root. And so we'll be left with 2x plus 1 over there. And then please, I see so many learners, even in like grade 11 and 12, who forget that you have to make 2 brackets over here. What they do is they just square the 2 and they square the 1. But you must do 2 brackets. You don't have to make the brackets if you know what you're doing. But for most learners, even when I was in grade 11 and 12, I always made 2 brackets. And I even sometimes still do that today, just to make sure. Okay, so there we go. I've gone and I've multiplied that out. I just did this one in one step, okay? But it would have been minus x and then minus x, but that would eventually make minus 2x. I'm then going to take everything over to the right-hand side. See what I did? I just moved this one over. So it became a negative over there, and then I also moved this one over, and it became a negative over there. So now I'm just going to quickly simplify. That gives me minus 4x, and then this cancels out. All right. Now what some learners do here at this next step, and I actually see this a lot, is they'll take the 4x over to the other side, and then they'll just cancel out an x, and then they say, oh, Kevin, the answer is x equals to 4. Do you know how many times I've seen that, guys? But it's completely wrong. That's not the way you want to do it. What you want to do is you keep everything on this side and you take out a common factor like that. Then you can say x is equal to 0 or x minus 4 is equal to 0. Therefore, x is 0 or x is equal to 4. So yes, we do get x equals to 4 like you said just now, but you would have left out this answer, and so you won't get full marks for that question. Now, pause there for a second. Or don't literally pause the video. That would be a bit awkward because you won't hear what I'm about to say. What I mean is pause, okay? When you're in your test, pause at this moment. What you must remember is that with square root equations, you must always check your answer at the end, okay? So we have to do a little check. So let's start with x equals to 0. So what I do is I go plug it in on the left-hand side, and I also go plug it in on the right-hand side of this equation. So if I plug it in on the left-hand side, I end up with 1, if you had to go type that in. And then when you use the 0 on the right-hand side, that's going to be 0 minus 1, which is minus 1. So your left side, I should actually say right-hand side here. Okay, now we also need to go check the right-hand side. And so if you say 0 minus 1, that's going to give you minus 1. So the left-hand side and the right-hand side are not the same, and so therefore that one is a NA for x equals to 0. Now we need to go try x equals to 4. Okay, so the way that we do that, we just go plug it in on the left-hand side. We also plug it in on the right-hand side. So for the left-hand side, we're going to say this over here, and then 4 plus 1, and that's going to give us 3. And then for the right-hand side, you're going to say 4 minus 1, which is 3. So that one works out nicely, okay? So the x equals to 0 is not a solution. Ooh, this one looks interesting. But what we need to realize straight away, guys, is that these two numbers are the same. So when those base numbers are the same, we actually just get rid of them, and we end up with this. Whoops, yeah, 27. Okay, now there are multiple ways you could do this, but what I would do is I would change this one. Because remember that if you have a root, like, and this is a B, or no, let's say this is a C, and this is a D, then the root formula or rule tells us that you can say that that's x to the power of c over d. So for this one, there's a 1 over here, and there's a magic little 2 over there, which we never write. So that can become x to the 1 over 2. Now, these two bases are the same. So if I think about grade 8, 9, 10 exponent rules, I just add these two together. And so that's going to give me x to the power of 1.5 or 3 over 2, like that. Right, now when you have a situation like this, you want to take this to the reciprocal, or the opposite. And then you do the same on the other side. Because what now happens is that this would cancel out. Because if you multiply those, because that's what the exponent rule tells us here, you multiply those, and so it just becomes a 1. And so we can just say x. Okay, and then on this side, if we want to be technical and not use a calculator, then we should change the 27 to 3 to the power of 3. Okay, and then you're going to multiply these ones over here, and that's just going to give us 3 to the power of 2. And so that's going to mean that x is equal to 9. With an inequality like this, all you do is you take everything to the one side, and then you factorize like normal. So let's go do that. We would make 2 brackets. For this one, it would be x minus 4 and then x plus 2. Now, you want to pretend that this was an equal sign. So just do it on the side here, though. We pretend it was a 0. So that means x is 4 and x is minus 2. These are called critical values, but these are not the answers. Okay, these are called critical values. So what you do is you just go make a little number line now, and you just put those numbers, those critical numbers, on the number line like that. Okay, then what you do is you look at this and you say, hey, that's a parabola, and because this number in the front is positive, it means it's a positive or a happy smiling face parabola. So what you do is you go draw that, just a basic little sketch going through those like that. Okay, then you look at this and you see, okay, they want to know where is the parabola smaller than 0. So what that means is, where is the parabola below the x-axis? Okay, some of you may have seen a video where I say it's like the ocean. If this is the ocean, they want to know where is the parabola below the ocean. So that would be over here. Okay, that is the below the ocean. So that would be, let me do that again. So that would be when x is bigger than minus 2, but then also smaller than 4. I'm going to show you a whole bunch of different ways you could write this, depending on what you prefer. So one of the ways is using the x equals to, or x element method that goes like that. Then some learners would prefer to do that. And then some learners might even go x is bigger than minus 2, but then if you want to say x is smaller than 4, then you must say and over here. You don't say or, you say and. Okay, whenever it's like linked together like this, we rather use the word and. If the answer was here and here, then you would use the word or in between. Okay, so these are the 3 different ways that I've seen learners try to use, and all 3 of those are correct. Given f of x equals to 5x squared plus 6x minus 7, solve for x to 2 decimal places. Guys, when they say solve it to 2 decimal places, you have to use the quadratic formula. Well, you don't have to, but what I mean is it's a hint. Like, you're not going to be able to factorize this thing using your grade 9 and 10 factorizing. You have to use the quadratic formula for that one. Alright, so if we're to go fill that all in now, you would say x equals to, now b is going to be 6, and then b would be 6 again, a would be 5, and then c would be minus 7. Remember that this is a, this is b, and this is c. And then at the bottom, we're going to have 2 times a, which is 5, once again. And so if we're to go work this out, to 2 decimals, x would be 0.73, or x would be negative 1 point, or comma 93. The next one, hence or otherwise calculate the value of d for which this thing has equal roots. Okay, so what we must remember is that if they say equal roots, Then we need to remember the discriminant. Remember the discriminant, which is b squared minus 4ac. Now that discriminant, we must make that equal to 0 if we want equal roots. So we're going to go take the discriminant, which was, but we'll have to start again here. So it's b squared minus 4ac. So it's 6 squared minus 4. Now a is 5, and c would be negative d. And we're going to make that equal to 0. So that's going to be 36 minus 20, and then that's multiplied by minus d. So that's going to become 36 plus 20d equals to 0. And so 20d is equal to negative 36. And so if you had to get d by itself, it would be negative 36 over 20. And if you had to simplify that, you get that d is equal to negative 9 over 5. Or you could say d is equal to negative 1.8. Any one of those would be fine. Simultaneous equations. Alright, so for 6 marks, but I want you guys to smile when you see this, because simultaneous equations are so easy, guys. What you do is you choose either this equation or this equation, and you try to get x, or you try to get the y by itself. I like to choose this one for this question, because I can easily get this x by itself. If I use this one, then I'm going to end up with weird fractions, and it's just going to make my life more difficult. So I'm going to get this x by itself, so we're going to end up with minus 3 plus 2y. And I should actually label these, so maybe we can call this equation 1, call this equation 2, call this equation 3. Now what I'm going to do is I'm going to substitute equation 3 into equation 2. Okay, so I'm substituting, I'm going to take this x and I'm going to put it in the place of that x over there. So I'm going to end up with minus 3 plus 2y, and then on the outside there'll be a y, which is this one here, and that's equal to 20. So I'm going to end up with minus 3y plus 2y squared equals to 20. I'm going to take everything to the left-hand side. I'm going to use the quadratic formula, but you can factorize this one. It does factorize. If you've solved this one, you should end up with y equals to 4 or y equals to negative 5 over 2. Okay, now what we do is we need to go get the x values. So we just plug it back into here. So I'm going to plug in y equals to 4. So that would say x equals to minus 3 plus 2 times 4. And so x is equal to 5. Then I'm going to plug in y equals to negative 5 over 2, and that would give us x equals to negative 3 plus 2 times minus 5 over 2. Okay? And so that's going to give us x equals to negative 8. With these types of questions, what you want to do is you just want to look at all of these numbers, these base numbers, and you just want to turn them into their prime numbers. So this is something we would have started doing in grade 10 already, and they sometimes like to add it now in grade 11 exam papers. So you're just going to change each of those numbers to their prime numbers, just using the shift fact method on your calculator. So, for example, if we take the number 4. Now, if you say 4 on your calculator and you say equals, then you say shift, and then you've got to look somewhere on your calculator, there is a button, or it's just written above the button, and it's called fact. That's what you want to do, okay? So, what you would see is that the number 4 can be written as 2 to the power of 2, okay? And then you're going to say n plus 1 over here. Then you're going to do the same with the number 8. Why didn't I do it with this one, by the way? Because that number's already in its most prime form. So the number 8 would be written as 2 to the power of 3, and then n minus 1. In the next step, we are going to go and multiply this 2 with the n plus 1, and we're also going to multiply this 3 with the n minus 1. And so that's going to give 2 to the 2n plus 2 over there. And what a lot of students do is they forget to multiply the 2 with the last part. And then at the bottom, we're going to have 2 to the 3n minus 3, like that. Now, what we do, we don't cancel 2's out and stuff like that. We can use exponent rules at the top. Remember from grade 9 and 10 that when these two numbers are the same, you don't multiply them, you just leave them as they are, but then you add the exponents. I know it's tempting to make these two turn into a 4, but that's not correct, okay? So what we do is we say 2 to the power of n plus 2 plus 2n plus 2. See what I did there? I just added the exponents. We'll leave the one at the bottom for now. And so at the top, you're going to end up with 3n plus 4. And at the bottom, you're going to end up with the same as it was. Now, do not cancel out these 2's. Remember your exponent rules. Your exponent rules, for example, if you have a7 at the top and a2 at the bottom, what do? You leave it as a. You don't cancel the a out. And then you say 7 minus 2, which is then 5. So that is exactly what we're going to do now. We're going to say 2. Then we're going to say 3n plus 4 minus, then in brackets, because we're minusing, 3n minus 3. And that's going to give us 2 to the 3n plus 4 minus 3n plus 3. And if we had to go work that all out, we should end up with 2 to the power of 7. Which you can then just type this in on your calculator, and that would be 128. With a question like this, we just need to understand the basics of square roots. So the way that square roots work is if you multiply a square root a multiplied by a square root b, then it just becomes the square root of both of those multiplied together. So if I want to multiply these two square roots, I'm not talking about this square root and this square root. We'll get to that later. But I'm talking about this square root and this square root. Then it just becomes a big square root, and then you put everything on the inside. Like that. You can put in a bracket because we're multiplying them together. Like that. Okay? The next step is let's go ahead and multiply out those brackets. So x times x is x squared, and then this would just give us minus x square root 2x minus 1. Alright, and then I'm going to multiply this part together, so that's going to give us plus x square root of 2x minus 1. And then we're going to multiply this part and this part together now, so that's going to become minus, and then a square root times a square. If these two things in the square root are the same, then it just becomes whatever's inside the square root. Okay, but you take the square root away. Let me show you what I'm talking about. Let's say you say square root 3 times square root 3. I did try to show this. Oh no, that was actually from a previous thing. Never mind. So square root 3 times square root 3 is the square root of 9, right? If we follow this rule here. But then the square root of 9 is just 3. So what I'm trying to say is that when you multiply the square root of two things that are the same, the answer just becomes that thing. Okay, so now we can just go ahead and neaten up. What I want you to notice is that this part and this part cancels out completely. So what we're left with now is x squared, and then minus 2x, and then plus 1. Now, if you go and factorize that, it's going to give you x minus 1 and another x minus 1. Now that is the same as x minus 1 to the power of 2. But now if you have to go use your exponent rules when you are in a square root, you know, like if you have x6 and there's a 2 on the outside, then you always take this side, the number on the inside, divided by the number on the outside. So that's going to give us x minus 1, and then the number on the inside is a 2, and the number on the outside is also a 2. We just don't write it there. So that's all going to cancel out, and so our final answer would actually just be x minus 1. First question, for what values of x will p be a real number? Okay, so we have to just quickly talk about when something is not a real number. Something is not a real number when you have a square root that is smaller than 0, or a square root that is negative. That is what we say when we have non-real. If you want real, then your square root must be bigger than 0. So you're actually not going to look at this part at all. Okay, so if we look at this 5 over x plus 2, we know, so then we can just say that x plus 2 must be positive, and then if you had to go solve, we'll just find that x must be greater than negative 2. Next question says, show that p is rational if x is 3. So rational just means it's a nice number. So let's just go sub it in. So we say p equals 2, and then square root 5 over, now x is 3, and then this would be plus 3 over 3. I just plugged in x as 3, and then that's just going to give you p equals to the square root of 5 over 5, which is 1 plus 1, and that's just going to give us 1 plus 1, and so the answer is 2. So that is rational. Okay, pretty random question, but that's how you do it. Calculate the sum of the digits of this number. Okay, so this, if you look at this and you're like, oh my goodness, what am I going to do? It is perfectly normal. I'm looking at this now and I'm also like, how are we going to do this one? But what I have sort of, this is actually really weird. Okay, so what I've identified in the past is that it usually helps to get these two numbers to be the same. So we could do something like 2 to the 2015 times by 5 to the 2015 times by 5 to the 4. Alright, so there is this rule, guys, that you must remember, that if these two numbers are the same, then you can actually just write this as like the following. You can just write it like that. It's almost like if you have ab to the power of 3, we know that that can become a3b3. But now what we did is we just took this one and we just wrote it backwards. Okay, and that's what I did here. See that these two are the same, just like these two are the same, so then you can just do it backwards. Okay, now that just becomes 10 to the power of 2015, and then 5 to the 4. Now look at this. If I say 10 to the power of 2, what does that mean? It means 10 times 10, which is 100. If I say 10 to the power of 3, it just means 10 times 10 times 10, which is 1,000. So if I say 10 to the power of 4, it's just 10 times 10 times 10 times 10. So it's just going to be 10,000. So we're just adding on a 0 each time. So imagine 10 to the power of 2015. Well, that's going to be 2015 tens that you multiply together. But the answer will probably just be a 1 in the front, or it'll definitely be a 1 in the front. And then there'll just be like loads. 2015, there'll be 2015 zeros. So let's just say that again. If we have 10 to the power of 2015, then that's just going to be a 1. And then there's just going to be 2015 zeros. Okay, so and then so that's fine. And then the number 5 to the 4, well, 5 to the 4, if you had to just work that out on your calculator, that gives 625. Okay, so if we had to then go multiply all of this together, so if this is 625, and let's just say this number was 1,000 or 10,000, doesn't really matter. When you multiply this, it's just going to stay 625, but then you're just going to keep adding on like loads and loads and loads of zeros. But they want us to calculate the sum of the digits. So they just want us to add these numbers together. So it doesn't matter how many zeros you add, because the planet where I'm from, if you add 0, it doesn't change anything. So we actually just need to go add the 6 and the 2 and the 5. So we can just say 6 plus 2 plus 5. This was just an example, by the way. It would be a number that's got 2015 zeros. But if you say 6 plus 2 plus 5, that's just going to give you 13. Given the linear, okay guys, remember, so linear is like it's where the first difference remains constant. So you can see here they're going from 5 to minus 2, so they're minusing 7, then they're minusing 7 again. Okay, so it's a linear pattern, it's not a quadratic. So it says write down the constant first difference. Well, that's just minus 7. Write down the value of term 4. So if you just go minus 7 again, that's going to take you to negative 16. Okay, then it says calculate the number of terms in the pattern. So we know that a linear pattern is Tn equals to An plus B. Your teacher might use a C over here or might use a totally different letter. Okay, if you are a grade 12 learner, you can even use your arithmetic formula like that. It doesn't really matter. Some schools use this in grade 11 actually. Sorry. Some schools use this one in grade 11. Alright, so we know that the last term is minus 289. So we can say minus 289 over there. Then A is the amount that you are... Now remember, for grade 11 and 12, the A is two different things completely. So just be careful about that. So for grade 11, in the grade 11 method, which is this one here, the A is the difference. So it's minus 7. And then B is, I mean, b, you can just leave it like that, to be honest. Now, what you do to there are different ways of finding b, but one of the ways that I think students prefer the most is to substitute a value in. So let's take this one. We know that this is position number 1, so n is 1. Oh, but I'm going to have to fill it into this formula again now. So we're going to say 5 equals to a, and then we have position number 1 plus b. So to work out b, you're going to get 5 plus 7, and so b is 12. Okay, so we just had to do a little side calculation here by plugging into this formula quickly. Now we know b is 12, so we can use b as 12 over here. There we go. So now you can solve for n. So I'm going to take the n to the left, and I'm going to take the 289 to the right, and so 7n would be equal to, what's that, 301. 301. And then 301 divided by 7 means that n would be 43. So there are 43 terms. A linear pattern has a difference of 3 between the consecutive terms, and its 20th term is equal to 64. So determine the value of term 22. Okay, so this one's only for 1 mark. Why? Well, it's easy. If term 20 is equal to 64, then term 21 would be 67, because you're adding on 3, and then term 22 would be 70, because you're adding on another 3, and so that is how you would get term 22 as 70. This one looks quite interesting. Which term in the pattern is equal to 3t5 minus 2? So let's first go work out what term 5 is. So to do that, we need a formula. So we know that for a linear pattern in grade 11, we can use this formula. If you are a grade 12 learner watching this right now, you are more than welcome to use the arithmetic formula, which is like that. But please remember that the a value is different in these two formulas. They are not the same thing. Okay, so I'm going to use the grade 11 approach, because most people watching this will be grade 11. So we know that a is the difference, which is 3. In grade 12, that is not the case, but yeah. Okay, and then there we have it. They tell us that, they tell us that the 20th term is 64. So term 20 is 64. So you can say 64 over here equals to 3 times 20, because that's term 20, and then plus b. So we can say 64 is equal to 60 plus b, and so if you had to get b by itself, b would be equal to 4. Now we can write down the formula, 3n plus 4. And so now we can go work out term 5. So to work out term 5, we just say term 5, and then we plug in a 5 over there, like that. And then 3 times 5 is 15, plus 4 is 19. Okay, so now we know what term 5 is. So we can now answer this question. So we can say 3 times 19, because that's what term 5 is, minus 2. And so that's going to give us 55. Okay, so now we know they're saying which term will be equal to this, which is 55. So now we have the formula. It's a really weird question. So now we're going to say 55 equals to 3n plus 4. And so now we're going to go see what n is. So if you bring the 4 over, you get 51. And then if you had to divide by 3, you end up with 17. And so it will be term 17 that is equal to 55. Here we have a quadratic number pattern. So remember, a quadratic number pattern is when the second difference becomes constant. So if you have 5, then 12, then 29, then 56, then to get the first difference would be 7, and then 17, and then 27. And then we can go work out the second difference, which would then be 10, and 10. So you see how it remains constant. Okay, so they want us to know what is the next two terms in the pattern. So what we do is we just continue this over here. So that would be 37 and then 47, right? Because you're just adding 10 each time. So if you say 56 plus 37, you get 93. And then 93 plus 47 is 140. So the next two terms would be 93 and then 140. prove that the first differences, which would be these ones over here, prove that they will always be odd. Okay, now that might seem like a weird question, or like you might think like, how do I show that? Well, what we must remember is that odd numbers cannot be divided by 2. Cannot be divided by 2. Like they'll always have a remainder. For example, if you divide 5 by 2, 2 can go into 5 twice, but then there will be a remainder of 1. If you say 11 divided by 2, it can go in 5 times, but then there'll always be a remainder of 1. So a number that is odd cannot be divided by 2, like fully. There's always a remainder. Okay, so what we're going to do, we're going to go get this formula for this linear pattern. So in grade 11, we typically use this formula here, an plus b. And so remember that this difference over here is your a, if we're using the grade 11 method. So that's 10n plus b. Then we need to get b. So to get b, you can just choose any one of these points or numbers. So I'm going to choose this one. Now I know that that 7 is the value of the term, so I put it there. And then this is term number 1, so I'm going to put a 1 over there. And then that means 7 is equal to 10 plus b. So if I had to get b by itself, I would get negative 3. So I now have the formula, so we can say that Tn is equal to 10n minus 3. And now I need to try show that this formula, no matter what, won't be divisible by 2. So I can say 10n minus 3 divided by 2, and that's going to give me 5n because of that. And then it doesn't work because, so that part went quite nicely, but then the 3 doesn't divide. So that's going to give me minus 3 over 2. So it doesn't divide properly. So because of that, we can say that the first differences will always be, the first differences cannot be even because they cannot be divided properly by 2. But if it was like 10n minus 4 and you divided that by 2, well, that would work nicely because that would just be 5n minus 2. Okay, so because it doesn't divide properly, we can just say then, we can just give them a little summary. Therefore, first differences will always be odd. First differences always odd. Consider the quadratic pattern 3, 5, 8, and 12. Determine the value of term 26. Okay, so it doesn't get any easier than this. Sure, for 6 marks, this is easy, guys, because we know how quadratic patterns work. So we know that that difference is 2, that difference is 3, and that difference is 4. Then we go down one more layer. There we go, and there we go. Then we just know that we've got these 3 formulas that we always use over here. So we can say 2a equals 3a plus b equals, and then a plus b plus c equals. Now remember, the basic formula of a quadratic is an squared plus bn plus c. So what we do is we start here at the bottom and we try to get a. So a would be, if you had to get a alone, you would get 1 over 2. Okay, so now we have a. Now what we do is we come up to this level over here, so that's 3a plus b equals to 2. So 3 times a half, because we worked out b already, and that's going to give us 3 over 2 plus b is equal to 2, and therefore b would be, if you had to work that out, b would also be a half. Okay, so b is a half. Now we come up to this layer over here, where we now have a plus b plus c equals to 3, but now we know that a is a half, b is a half, and so we can work out c as, if you had to go do all the maths, you would find out that c is equal to 2. So now we have the formula, Tn is equal to a half n squared plus a half n plus 2. So now to find term 26, we just go plug in 26 wherever we see n. And if we had to work this out, we get 350. Whoop, let me write that a bit better. 353. A certain quadratic pattern has the following characteristics. Term 1 is that, term 2 is that, term 4 is that, and term 3 minus. Okay, so this looks messy, right? And we need to find the value of term p. But let me show you what we can do. So we know that term 1 is p, term 2 is 18, term 4 is 4 times term 1. So term 4, okay, so we don't know what term 3 is, but we know that term 4 would be 4p, because they said that term 4 is 4 times term 1, and term 1 is p. Then it says term 3 minus term 2 is 10. What that means is that this difference is 10. So that means that this is 28. So that this difference is 10. Because they said term 3 minus term 2 is 10. So if you wanted to, if you didn't know what this one is, you could call it an x, and then you could say x minus 18 is equal to 10, and then x would be 28. Okay, so we know that that one is 28 now. What we can now do, I think the best thing we could do now is just to keep filling in the differences. So we know that this is 18 minus p. This will be 4p minus 28. And then we go down one more level. So this would be 10 minus, in brackets, 18 minus p. And then this difference would be 4p minus 28 minus 10. Okay, so remember it's always this one, the second one, minus the first one. And then it's the third one minus the second one. It must always be the one on the right minus the one on the left. Okay, so if we had to just quickly simplify this one a little bit, we could say 10 minus 18 plus p. And then, okay, so I'll just fill that in quickly. 10 minus 18. Whoopsie. Now here's the part where students, sometimes they're like, okay, what do we do now? Well, remember, they told us that it's quadratic. So what do we know about a quadratic? We know that the second difference, so that's the first difference, that's the second difference, this one here, we know that that's the same. So we can make these two expressions equal to each other. So we say 10 minus 18 plus p equals to 4p minus 28 minus 10. And now we just solve for p. So that's going to be minus 8 plus p on the left, and 4p minus 38 on the right, and then we can just solve for p. So we can take that to that side, and then this would become minus 8 plus 38, and so 3p is 30, and so therefore p is 10. Please note that these questions do carry on, so here's point 1 and point 2, point 3 and point 4, and then point 5. Alright, so the sketch below shows the graph of this hyperbola. A is the point of intersection of the asymptotes of f. Okay, so this is where the asymptotes intersect. Write down the coordinates of A. Right, so that's quite easy. So we need to know what this does to a graph. Let me make that a bit better. This part here. So we need to know that x minus 1, what does that do? It moves the graph one place right. What does this do to a graph? Well, that moves it 2 places down. So that moves 2 units down. So if you can imagine, the most basic hyperbola that you can ever get would have started at the origin. That's where the center would have been. But then you would have moved it 1 place to the right and 2 places down. So the coordinates of A would become 1 and -2. The next one for 5 marks. Determine the coordinates of the x and y intercept. Very easy. Hey guys, x-intercept, make y0. Y-intercept, make x0. That'll never change. That's a constant rule that we can always use. So to find the x-intercept, we make y0. So we say 0 equals to -9 over x minus 1 minus 2. Now I'm going to take the 9 over with the x minus 1 so it can become positive. Then I just cross multiply. So I just multiply this x minus 1 up. It's almost like I'm getting a common denominator. So I end up with that. And then 9 is equal to minus, whoopsie, what's going on there? Minus 2x plus 2. Then we're simply going to solve for x. So if I take the 2x to the left and take the 9 to the right, then x would eventually equal to -7 over 2, which is the same as -3, 5 if you want. So for the answer here, you would say, don't just say -7 over 2, say -7 over 2, and then also give the y value. Okay, now we need to go find the y-intercept. To do that, we make x0. So we can say y equals to -9 over 0 minus 1 minus 2. And so if we had to go work that out, we're going to get 9 minus 2, which is 7. Okay, so the y-intercept would be 0 and 7. Always give the 0 as well. So what we know so far now is that a is 1 and negative 2. This point here is minus 7 over 2, and 0 is the y-intercept, is 0 and 7. This question, write down an equation of the axis of symmetry that has a negative gradient. So we know that that hyperbolas have two axes of symmetry. You've got the one going that way, and this one always has a positive gradient, and it's always positive 1. And then you've got this other one that goes that way, and this one always has the negative gradient, and it's always negative 1. See how I've got a negative 1 there? You can fill in the 1 if you want, and then this one always has a positive 1. That's always the case with hyperbolas. Now, they've asked us, write down an equation of the axis of symmetry that has a negative gradient. So they want this one. Okay, so we can say that y equals to negative x plus c. Then to find c, you just plug in this point over here, which is 1 and negative 2. So you can just fill that in. And so c would be equal to negative 1. Okay, so this dotted line, I haven't drawn it perfectly. It was just a drawing, but if its y-intercept is negative 1, that's like here. So it probably goes more like that. Okay, so then the equation would be y equals to negative x minus 1. For 5 marks, hence or otherwise determine the coordinates of a point that lies on F in the 4th quadrant, which is closest to point A. Okay, so they're talking about this point over here. So there are multiple ways that you can do this. Option 1, which is the option I don't recommend because I think it'll just take quite long. But that's where you can literally take this new line that we've just worked out. We worked out its equation as this. And we simply substitute that into this equation. And that'll tell you where the two equations intersect, which would be here. And it would also be here. And that's what we would be looking for. However, the better option, okay, so that would be the simultaneous, or sorry, if you make y equals to minus x minus 1 equal to f of x. Okay, that's option 1. Option 2 is, if we remember grade 10. In grade 10, we learnt about hyperbolas, for example. So like you'd have this, and you'd have this. And let's say they gave you y equals to 2 over x plus 4. Then we had a way where we could easily work out this point and this point. All that you did was you took the square root of this number. So you take the square root of 2. So then what would happen is that this one would be the square root. Okay, let's not worry about the plus 4 for now. So this would be square root 2 for the x, and then square root 2 for the y. This one would just be also square root 2, but negative, because the x is negative, and then the square root y, and the y would also be negative. Okay, and then for example, if we had it in the other quadrants, so maybe we have it in this quadrant and this quadrant, then this one here would also be square root 2, but it would have a negative x value. You just got to sort of look at the dot and be like, hey, does that have a negative x or a positive x? And then it would have a positive y. And then this point over here would have a positive x, and then it's got a negative y. You see? And then, okay, so then if I had to say plus 4 over here, then that would move the graph upwards by 4. So what you would do to each of these points is you would just add 4 to the y value. Okay? And you just add 4 to the y value. Now, in grade 11, we can also move the graph left and right, and up and down. Okay, so what we'll do is, okay, so to start off, to find this point over here, we take the square root of this number. You don't worry about the negative, you just take the square root of the 9. So that's going to be square root 9 and square root 9. Okay, but now that's not the answer. Now we need to do some modifications. First of all, this point here always has a positive x and a negative y. So we're going to make it the negative y. The x, we can keep it as positive. Next, we need to modify it. This thing has moved one place to the right, so I need to add 1 onto that. And then it's moved 2 places down, so I need to subtract 2, like that. And so if we had to go work all of that out, we should end up with 4 for this part, because square root 9 is 3, and then this would end up being minus 3 minus 2, which is minus 5. So that's the option I recommend, as it's a lot faster. But if you did want to use simultaneous, I don't think it would actually be that bad. You make this equation equal to that equation, and so that would be minus x minus 1 equals to minus 9 over x minus 1 minus 2. And then you would just go ahead and solve that over there. Okay. Now, oh, that's the end of that one. Or that question. Now we still have another one. Okay, so let's just quickly summarize what we have so far. We know that this was 0, 7. We know that this was minus 3. No, this was minus 7 over 2. 0. We just worked out this point here is 4 and minus 5. And then we also knew that this axis of symmetry was y equals to minus x minus 1. And that's about what we have found so far. So it says the graph of f is reflected about the x-axis to obtain the graph of g. Write down the graph of g's equation. Okay, so we're going to reflect it across the x-axis. So we're reflecting it across the x-axis. So in general, if you have a point, let's say this point is 2 and minus 1. No, that wouldn't make sense. 2 and 3. And let's say this is your x-axis. If you reflect something across the x-axis, the x value stays the same, but the y value switches. It becomes the negative. So what we do is we write down this equation, the original one. Then you switch the y to become a negative, because we said that's what happens. Okay, so what we do is we just make the y negative. So I just wanted to rewrite that again, like that. And then you're just going to get the y by itself. So you're just going to divide everything with a negative. So this all ends up becoming positive, like that. You see? So so it all just becomes positive like that. All right, and that's the end of that question. We are given an equation that has an x in the exponent. So this is definitely an exponential graph. The first question says, determine the coordinates of the y-intercept. Now, to find a y-intercept, we know from like grade 9 already that you always just make x equal to 0. So let's go do that. So I've gone and I've filled in a 0 wherever I see an x, and so this will just become 4 times 1, because anything to the power of 0 or negative 0 just becomes a 1 plus 1, and so this would just be 5. Now, don't just say 5, you must tell them that the x was 0 and the y is a 5. Next one, explain why h does not have an x-intercept. So guys, if you have an exponential graph, there are many exponential graphs that don't have x-intercepts. For example, if your graph does that, see, it'll never hit the x-axis. It'll just run along that direction like that. Maybe you have one that does that, for example. So there are many exponential graphs that don't have x-intercepts. Okay, so let's have a look at this one. Now, with questions like this, you don't have to explain it really if you don't want to. You can, well, I mean, you don't have to only use words. You can also go prove it mathematically. So let's do that. I think that's a better approach for most people. So what we do is to find, let's pretend we wanted to find an x-intercept. Well, to do that, you make y 0. Okay, and now we're just going to try solve. So you take the 1 over to the other side, and then you can divide by 4. All right, now let's bring the 4 back to the top. So let's bring that 4 up. So the way that you can bring something to the top is you just do, so you can say minus 1 and then times 4, but then you must say 4 to the minus 1 because you've brought it up, whereas this 4 did have an exponent. Whoopsie, this 4 did have an exponent of 1, but then you bring it up, so then it becomes like that. And then we can go equals to 2 to the negative x. Okay, now let's change this 4 to 2 to the power of 2. So like that. And then we can do that. See what I did there? And then, okay, this minus 1, you can just leave it as a minus. I don't know why I did that. Okay, now we're just going to multiply this together. So it just becomes 2 to the negative 2 equals to 2 to the negative x. Now, you cannot solve this thing. I mean, for grade 12 learners watching this, I mean, you could try using logs, but it's just going to give you an error on your calculator. And then for the normal grade 11 approach, we would normally want to cancel these out, but we can't in this one because this random negative is there, and that negative is the problem. That's getting in the way. So you could say here that this equation cannot be solved, but we could even if we came back to this part here, we didn't actually have to go that far. What we should know is that this part here is always positive. I encourage you to go take this, type it on your calculator, and fill in as many different x values as you can. That thing there will always be positive. It won't even be 0. It will always be positive. So you can actually just tell them that at this step here, you could just say 2 to the power of minus x is positive, which means bigger than 0 for all x values. So for x is an element of R. So that means for all x values. And then you can just stop there. That's why we can't solve it. And just a word on that quickly. You must remember that, guys. If you have an exponential like that, or even if it has a negative, that thing is always positive. You can go ahead, go type in as many different x values as you want, or put in different x values into that equation. This thing will always be positive. Yes, you can make the number very small. You can get this to become very small, but you'll never get it to become 0, and you'll never get it to become negative. Okay? So as soon as you get something like that, just know that that thing is always positive. So if you have an equation that looks like this, well, that's impossible, because this can never equal something that is negative. Okay? Next one, draw a sketch graph clearly showing all the asymptotes, intercepts, and at least one other point. Okay, so there they've made this really nice. So in some of our lessons, what we've spoken about, if you've seen that lesson in that video where I spoke about that, it was a lesson where we talk about how to draw an exponential graph. And normally, if you want to draw an exponential, normally you just need a y-intercept, an x-intercept, and the asymptote. From that, you can get a perfect graph, and it's easy to see what the graph looks like. But what if there is no x-intercept? Then you don't have enough points. Then you only have a y-intercept, and you only have an asymptote. So then what you do is you still go get your y-intercept, you still get your asymptote, but then you get a random point. One other random point. And now here in this test or exam, they actually tell us this, and at least one other point. So that's really nice. Okay, so let's do it. We've got the y-intercept. We got the y-intercept as 0 and 5, so let's go plot that. Remember, these drawings never have to be according to scale. Please don't go take a ruler and draw 5 lines, and that's crazy, because sometimes these numbers are like 40 and 30, so it never has to be according to scale. So just say 0 and 5. Okay. We've got an asymptote. It's always this number here. So that's y equals to 1. So we can put a dotted line at y equals to 1. Remember to fill that in. Y equals to 1. Then we need one other point. So make it easy for yourself. Let's let x equal to 1. Let x equal to 1. So we're just going to go plug that into the equation now. So that's going to become 4 times a half plus 1, which will be equal to 3. So that's a point 1 and 3. So we go to the place where x is 1, y is 3. It's probably somewhere over there, and we can label that one. Okay, 1 and 3, and then we can just connect the dots. We know it's exponential, so it either does that, or it does that, or it would be below, or below, something like that. But we know through the dots, it's going to be this shape. Whoopsie, Kevin. Like that. Okay. And then the next question. Describe the transformation from h to g if g of x is equal to this. Okay. Okay, it's actually a really silly question, guys. I'm just going to quickly multiply this 4 in. So it's just going to become 4 times by 2 to the minus x. Well, let's just go write this down. Okay, so there we have it. Now look at this. Oh, by the way, you can't make this equal to 8, eh? You can't multiply these two numbers because of that exponent over there. I know that caught some of you. So if you just look at this and you look at this, what's the only difference, guys? The 8 and the 1. So how do you go from having this graph to having a plus 8? How do you make this a plus 8? What do you do to that graph? Do you move it left, right, up, down? What do we do? If you want to turn this into a plus 8, you move it 7 units upwards, because you'll just add on 7 units, and then that will just become plus 8. So we'll say describe the transformation from H to G. We can say shifted 7 units up. So these questions are going to carry on onto the next slides. So here's 6.1 and 6.2, and then it does go to 6.3 and then 6.4. Okay, so the sketch below represents the graph of two parabolas, f and g. They give us the equation of f, okay, so just always make sure that's this, okay, that's this one here. Then the turning point of g is 2 and 9, the y-intercept 0, 5, b and d are the x-intercepts of f and g respectively. Show that the equation of g is that for 4 marks. Now, there are only 2 ways that you can find the equation of a parabola. Let me quickly remind you. If they give you x-intercepts, both of them, well, sometimes there is only one if it turns on the x-axis. Okay, but that's another story. So if they give you the x-intercept, use this formula. Okay, don't forget the a. If they give you the turning point, then you use this one. Okay, that is how we do this for parabolas. All right, so what have they given us in this question? Well, they've given us a turning point, so we're going to use this one. You don't worry about this for now. It'll get there by itself. So we're just going to say y equals to a bracket x minus p squared plus q. And then remember that this here, the turning point is 2 and 9, so that means the graph has moved 2 places to the right and 9 places up. Then to find a, you plug in another point, so we'll use 0 and 5. So the 5 is a y value, the 0 is an x value. And so we can say 5 is equal to, now this part here just becomes 4a. 4a plus 9. Remember that this 9 is not part of the a. Some students do put them together. Now we're going to take the 9 over to the other side, so 5 minus 9 is equal to 4a. So minus 4 is equal to, minus 4 is equal to 4a. So a would be minus 1. Now what you do is you just put the a back into this equation. So I'll write over here, so y is equal to minus 1. And now we're just going to go multiply this all out. So how do we do that? My suggestion, put these into 2 brackets first, because you can't put the minus 1 inside there until you've done, let's first do the brackets. Okay, so minus 1. Okay, leave the answer of those brackets over here. So x squared minus, that'll become minus 4x plus 4 plus 9. Then put the minus 1 in. And then simplify. Sorry guys, I'm going to write that down here now. So y equals to minus x squared plus 4x minus 5. And that's how we do it. All right, so I hope that makes sense. Next one says calculate the average gradient. Okay, now when you see the word average gradient, I just want you to think of gradient. Just think of gradient. You know, y2 minus y1 over x2 minus x1. That's all that it means between a and c. Okay, the only reason they're calling it average is that if you connect, if you look at a and c, it's not a perfect straight line. There's a bit of a curve there, right? But they want you to pretend that it's a straight line. So that's why they say the average. But you can ignore that part. Okay, so we know that that's the formula for gradient. So I'm going to let this one be point number 2 and this one be point number 1. So we can say that m is equal to 9 minus 5 over 2 minus 0. And that's going to give us 4 over 2, which is then equal to 2. This one says calculate the length of BD. Now it's a very easy question. They want you need to find the coordinates of that, and you need to find the coordinates of that. Okay, so we know that the equation of G, remember we did work that out in the previous question as negative x squared plus 4x plus 5. So all that we really need to go and do is find the x-intercepts of f, and then also find the x-intercepts of D, and then we can easily do this question. So let's start with f. So let's go find its x-intercepts. To find the x-intercept, you make y equal to 0. Take the 8 over. You can multiply this 2 across, or you can say 8 divided by half, whatever you prefer. It's both the same. And now we take the square root, and remember you always say plus and minus. Okay, so that one has x-intercepts at plus and minus 4. So that means that b would be negative 4 and 0, and then this point here, which they haven't labeled. Okay, we don't have to go fill that point in. So there we go. Now let's go do G. So G is negative x squared plus 4x plus 5. I shouldn't actually say here. So B, therefore B is negative 4 and 0. Okay, now we're going to go do the same for this one. I don't like working with the negative, but you can if you want to. But I'm just going to divide everything by negative. This one would actually factorize. But if you wanted to, you could also just use the quadratic formula. Nothing wrong with that. Okay, that's how that one factorizes. And then therefore, x would be equal to 5, or x would be equal to minus 1. Okay, so this is obviously the minus 1, but we want the one with 5. So we can then say, therefore, D is 5 and 0. Now, you can easily get the length from here to here. You don't even have to use the distance formula. Think about it. You're going from minus 4 up to 5. How many units is that? That's 9 units. Therefore, the answer is 9 units. If you wanted to use the distance formula, it would still work. So that is okay. This question says, use the graphs to solve for x if f of x must be bigger than 0. So remember, when they say bigger than 0 like this, they're talking about, sometimes I call this the ocean. I call the x-axis the ocean. You know the ocean where there's like fish and boats and all of that. Then we always say that this area here is above the ocean, and then this area here is below. So when they say that they want to know where the graph is above or bigger than, it means above. So that's what they want to know. They want to know, where is the graph f above? So if you look at graph f, it's above over here, and then again over there. So you could simply say, and I'll show you the different ways of answering. Like you could use, some people prefer to use brackets, some people prefer to use the interval notation, the set border notation method. I'll show you guys. So we could say, here's one way of saying it. You could say that, so for this area here, you would say x is smaller than minus 4, but you can say smaller than and equal to, because that's what they've got. And then you would say, or, don't say and, you would then say x is bigger than or equal to, oh no, that's a 4 here. 4. There we go. So, okay, so that's for that area over there. If you prefer to use the brackets, you could say x is an element going from negative infinity up to negative 4. Or you could say or you could say or like that. And then you would say from 4 to infinity. All right. And then that's for 6.4.1. Now for 6.4.2, it says, where are the graphs f and g strictly increasing? Okay, so what does increasing mean? Well, increasing is when the graph is going up if you look from left to right. So this area here, that is not increasing. That is going downhill. Can you see that? So where are both of the graphs going uphill? Well, what we do is, let's go find out where one of them is going uphill. So let's see, where's f going up? F is going up here. Okay, that's where f is increasing. And then where is G increasing? Well, G is increasing over here. See, it's going up, 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 up to there. Okay, so where is the overlap? The overlap is going to be from this y-axis up to this turning point. Can you see? Yeah, at the turning point there, sorry. So in that area, in that region there, both graphs are increasing. So we will just say, I'll show you the different method, but you could say when x is bigger than 0, because that's the y-axis. We're not going to include the y-axis, because at that point, the yellow graph, or the graph of f, is not increasing. It's probably flat over there. So, and then we could say smaller than the x value over here, which is 2. If you prefer to use the bracket method, you could say x is an element going from 0 up to 2. The sketch below shows the graphs of f of x and g of x. Okay, so we have a straight line and we have a parabola. C is any point, blah, 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 such that CD is parallel. Okay, so we know that this is parallel to the y-axis. K is a value that C lies above D. Okay, so K we don't know, but K is such that C is always going to be above D. Okay. It says write down a simplified expression for the length of CD in terms of x and k. Okay, guys, so this is one of those typical questions that they love asking in grade 11, where they ask you something about the minimum or maximum length, vertical length, between a straight line and a parabola. And all that we do, you've maybe seen some of my videos, all that we do is we just want to use the technique that we call y top minus y bottom, and then you make that equal to the length of CD. So what do I mean? Well, the top is the straight line. Can you see the straight line is on the top? So you put its, you replace its y with 2x plus 3 minus, and now we just put the bottom graph, which is this one, but it must go in brackets because we are subtracting. Like that, and then you make that equal to CD. Now you just want to go simplify all of that, so that's going to be 2x plus 3 plus 2x squared minus 14x minus k equals to CD, and now we just put all like terms together, so that'll give us 2x squared minus 12x plus 3 minus k, and that is the expression, the simplified expression for the length of CD in terms of x and also in terms of k. They now tell us if the minimum length of CD is 5, calculate the value of k. So now they're giving us the minimum length. So they're saying that the length is 5, calculate the value of k. Alright guys, so how would we normally, let's say we had this equation here. How would we normally go find the minimum or the maximum? How do you find the minimum or maximum of a quadratic equation? Well, this is where you would just say minus b over 2a. So the x value of the maximum or the minimum, we always find that using minus b over 2a. So let's go do that. So we could say minus 12, because b is minus 12, over 2 times a, which is 2. And if we had to go work this out, we end up with x equals to 3. Okay, so the x value is 3, and the value of CD is 5 when it's at the minimum. So what we can do now is we just go substitute that 3 into this equation. And then we know that when we do that, the length of CD is 5. And then we can just go solve for k. So it'll be 18 minus 36 plus 3 minus k equals to 5. I'm going to take k over to the right-hand side. And if you guys are to solve this, it's pretty straightforward. We should end up with k being negative 20. A school buys tablets at a total cost of 140,000 Rand. If the average rate of inflation is 6.1% per annum, determine the cost of replacing these. Okay guys, so a school is going to go buy a whole bunch of tablets. You know, like the computer tablets, and that's going to cost 140,000 Rand. In 4 years' time, the school's going to buy more tablets. Now, would the cost normally go up or go down? What happens in real life? What happens to things? in the shops, the value goes up, right? It's called inflation. If you buy a car today, it might be 100,000 Rand. If you try to buy the same model in the future, obviously it'll be a newer model, it's going to be worth more, okay? Things go up in value. You know how your parents always say, oh, you should see how much I paid when I got myself a Coke back in the day. And it's like, yes, mom and dad, it's called inflation, okay? It's nothing magic. It's just inflation. All right. So, we're just going to use the normal a equals to p 1 plus I to the power of n formula, where we can say a is what we're trying to find, 140,000 is what we are starting with. The inflation rate is 6.1%, so I like to say 0.061, because I just divide it by 100, and then we're going to do that for 4 years. Okay, we're not going to say over 12 because we're not doing monthly. We're doing per annum. That's how depreciation and inflation works. So if you had to go work that out, you're going to get a value of 177,414 and 69 cents if we round off to 2 decimal places. An investment earns interest at a rate of 7% per annum compounded semi-annually. Calculate the effective annual interest rate. So it's one of these where we have to convert between effective and nominal. So they don't give us this formula on the formula sheet, but the way it goes is like this. Let's actually make this a little subscript. Okay, then you do this, and you go 1 plus I nom over m to the power of m. Okay, so what you do is they want us to calculate the effective, so they want us to calculate this one, so we leave that alone for now. So we go 1 plus I effective. Sorry, let me make that a little subscript. And then that's going to become 1 plus, now 7% is 0.07. Semi-annually, that means twice a year. I know it's every 6 months, but you don't put a 6 there. It's 2 because it's twice a year, and then this number must always be the same as that one when you're using this equation. And so I don't like to use the calculator just yet. What I'd rather do is do this, that, and then say minus 1. And then I would go type this all in on the calculator. And then whatever you get there, before you round off, multiply that with 100. Before you round off, guys, multiply it with 100. It affects your answer quite a lot. Okay, so I've just said that. Then I say times 100. And now I can round off to 2 decimal places. That's going to be 7.12%. But what some students do is they take this answer, which we got earlier, and then they round that to 2 decimal places. And then they multiply that with 100, and then they get 7.1%. So it changes it. You see that? So you don't want to round off until you've multiplied with 100. A savings account was opened with an initial deposit of 24,000 Rand. Okay, so this is definitely for 5 marks. We're going to use a timeline. 18 months later, 7,000 Rand is withdrawn. Calculate how much money will be in the savings account if the interest rate is 10.5% per annum, compounded monthly. Okay, this one's not too bad. They're not changing the interest rate, and they're just doing a deposit and a withdrawal. Whereas we've done questions before where we do deposit, withdrawal, and we change the interest rate all at the same time. Okay, so let's just draw a basic little timeline. So we start here at the very beginning, and they want to know what happens after 4 years. So we start off by adding 24,000 Rand. Then 18 months is 1.5 years, right? 1.5 years. So I'm going to say at T 1.5. We are going to withdraw, so we're going to take money out. How much are we going to take out? 7,000 Rand. And that's it. Now the interest rate is going to be fixed at 10.5% per annum, but that is monthly. Okay, guys, so we know how we do these questions. All we do is we look at each amount. Okay, so we start with the 24,000. So we go 24,000. And we just use the normal formula. So we go 1 plus. Then the interest rate is 10.5%, which is the same as 0.105, compounded monthly. And how long is this one going to be in the account for? Remember, what you do is you take it from T0 and you take it all the way to T4. And so that's going to end up being 4 years. So you can say 48 of a year, or you can say 4 times 12. And then what we do is we just simply move to the next one. So now the next one is the 7,000 over here. So we're just going to say minus, why? Because we're taking the money out. So we're going to say minus 7,000. And then we're just going to do the same thing. So 1 plus 0.105 over 12. Now how long is it from here to here? Well, that's going to be 2.5 years. So you can say 2.5 multiplied by 12, which is the same as 30. And now we can simply go and calculate all of this in one step. And the final answer there will give us 27,369.56. A car costing 198,000 Rand has a book value of 102,000 Rand, or 102,755. So what does that mean? It means that you purchased a car for 198,000 Rand. Now you obviously drive your car, it becomes a little bit older. So the value of your car goes down, right? And this is called the book value. So that's what your car is worth after 3 years. It says if the value of the car depreciates, which means becomes less, at R% each year, calculate R. So because it's a depreciation, we're going to use this formula. Okay, so we're just going to use a minus because it's becoming less. Now, be careful. A lot of students, they always want to put the bigger number here. But you must remember what A means. A is the final and P is the start. So how much was the car at the start? Well, 198,000. How much was the car finally, or after a few years? 102. So that's where the 102,755,34 goes. And then the 198,000 is actually the P value. So it's not about putting the big number and the small number. It's about the starting number and the ending number. Now the interest rate, we don't know, so we'll just leave it like that. Some of you might be like, yeah, but we must divide by 100. Yeah, we can do that later maybe, guys. We can just leave it like that for now, and then it's for 3 years. Okay. Now we need to eventually try to get I by itself. So what I would do is I would divide by 198,000 on the left-hand side. Like that. Then what we have is 1 minus I to the power of 3. So to get rid of this 3, we're going to have to do a cube root on both sides. So we're going to cube root over here, and then we're going to cube root on this side. But what this does is it cancels out that 3. Okay, I'm not touching my calculator yet because I don't want to have to round off and all of that stuff. I want the most accurate answer, so I just keep writing it down like this. And now what I have on the right hand side is just 1 minus I. The 3 has cancelled. What I then do is I take this I, well you don't have to, we can actually leave it on the right hand side as a negative. And then on the left hand side we would have the root, or the cube root. And then I'll just say minus 1. Okay, and then I can go type this on my calculator now. And then before you round off, remember to multiply your answer with 100, or you can first divide by -1 just to get rid of the negative, but then after that, don't round off, and then multiply your answer with 100 to see what I will become. Okay, so if you had to go do all of this correctly, you should get a final answer for I as 19.64%. So we are given the probability of A, probability of B, and then we're also given probability of A or B. Are the events A and B mutually exclusive? Justify your answer with calculations. Right, so what is mutually exclusive? Okay, let me explain. Mutually exclusive looks like this. That is what mutually exclusive is. It is two events, A and B, that cannot happen at the same time. For example, you cannot have someone who does maths and maths literacy. Okay? People who do maths and then people who do maths literacy, but you can't have people who do maths and also do maths literacy at the same time. Okay, that is what mutually exclusive is. Mathematically, what does it mean? It means that P of A and B equals 0. This is what mutually exclusive means. So on most formula sheets, you are going to be given a formula like this. This is like the basic formula of probability. On some formula sheets, they might have it as A or B like that. Then they'll have P of A plus P of B minus P of A, and then sometimes they show it like that. Okay, so that's the and that's the or. So what we'll do is we'll just go use this formula. So we've been given the 0.8 as that part. Then the P of A is 0.6, P of B is 0.3, and then P of A and B is what we are going to go calculate. Now, if you had to go calculate this, what you would find is that it will be equal to 0.1. So are these events mutually exclusive? No. Events are not mutually exclusive. Why? Because P of A and B was not equal to 0. Just want to make mention that this question does carry on the next slide. The table below shows data on the monthly income of employed people in 2 residential areas. Okay, so let me try to explain. The way that this table works, so in area 1, there are 500 people who earn less than 3,200 Rand per month. There are 1,182 people who earn somewhere between 3,200 and 25,600 Rand, and then there are 150 people who earn more than 25,600 Rand per month. Okay, and then obviously area 2 they go through the same, and then here's the totals. First question, what is the probability that a person chosen from the entire sample will be from area number 1? Okay, so there are this many people, so that'll go at the bottom. From area 1, you would add up all of those numbers, so it'll be 1,832. Then just go ahead and type that in on the calculator so that it can simplify. And that's going to give us 916 over 1323. And then you can leave that as you can change that to a percentage if you wanted to as well. The next question, what is the probability that a person will be from area 2 and earn less than 3,200 Rand per month? Okay, so we got to look at area 2. Well, first of all, they said that we're choosing from the entire sample. Okay, so we know that the fraction is going to be everyone, so that's 2646. Okay, now they want this person to be from area 2, and they must earn less than 3,200 Rand per month. So it's these people. So that's 460 people. Now, if you type that on your calculator, you'll get 230 over 1323. All right. Now the next question is a person from area 2. Okay, so it's a person from area 2 who earns more than or equal to 3,200 Rand. So it's people who earn 3,200 Rand or more. So that would be these people, but also these people. So if you had to add those up together, that will be 354. 354 out of 2,646. And so that's going to be 59 out of 441 as your final answer there. Prove that earning an income of less than 3,200 is not independent. Okay, so I'm not really reading any of that stuff. All I know is that they're looking at independent. So what must we do when they say independent? Because they like to ask this in exams. So independent means the following. Okay, so if this formula is true, then we call this independent. Okay, if this formula is true, if this is true. Okay, so it says, so now what we do is we just go look at these things. Prove that earning an income of less than 3,200 Rand, because that's the first thing. Income of less than 3,200 Rand is not independent of the area, is not independent of the area. Okay, so let's choose area 1. Okay, so let's just choose area 1. So event A can be income less than 3,200. Okay, and then let's let event B be area 1, people who live in area 1. Okay, so what we need to go do is we need to go work this one out first. So we need to go work out P of A and B. So what is that? That is probability of income less than 3,200. Income less than 3,200 and who live in area 1. Okay, so where are those people? They live in area 1 and they have an income less than 3,200 rand. So that's 500 people out of the total. So that would be 500 people out of the total. Okay, and if we had to just quickly work that out, we get 250. Actually, let's keep this one. Okay, no, that's fine. Let's keep it as, let's write it as a decimal, because these types of questions, it's easier with decimal for these independent questions. That's going to be 0.18896. 0.18896. Okay, now so we've done this part of the formula. Now we need to go get this one. So that would be probability income less than 3,200 rand. So that would be 960 people, because now they're not only saying area 1, now they're saying out of everyone 960 people. So that would be 960 people out of 2646, and if we work that out, I'm going to keep it to 4 decimals, so that's going to be 0.3628. Now we need to go work out so we've done P of A, now we need to go get P of B, which for us is people who live in area 1. Okay, so P of B is all the people who live in area 1, which is 1,832 people out of the total once again. And if we work that out, 0.6923, 0.6923. Okay, so now what we need to go and do, so we have P of A and B. Where did we write that answer down? Okay, that was this one. Okay, now what we need to go and do is we need to go multiply P of A and P of B together and see what that gives us. So where's P of A? P of A is here, and then P of B is here. So if we multiply those two together, then that's going to give us 0.3628 multiplied by 0.6923. And let's see what we get. 0.2511. So that's going to give us 0.2511. Now, okay, so now what we do is we see, is this answer the same as P of A and B, which is this one over here? No, they are not the same. So we can say that P of A times B is not the same as P of A times P of B. Okay, so therefore it is not independent. And that's what they asked us to do. They said, prove that earning an income is not independent. Okay, so we can say, therefore, not independent. If this side was exactly the same as this side, then we would say that it is independent. Which is more likely, a person from area 1 earning less than 3,200 or a person from area 2 earning less than 3,200? Show your calculations to support your answer. Okay, so let's just go find person from area 1 less than 3,200. Less than 3,200. Okay, but what they mean is that if you had to go visit the people in area 1, or if you had to go visit the people in area 2, which one is more likely? Would to see a person in area 1 with less than 3,200 rand, or a person in area 2? So for this one, we're only going to use the area 1 people. We're not going to use everyone. We're going to use the area 1 people. So that's 1,832 people. Earning less than 3,200 rand would be 500 people. And so if you had to work this out, as a decimal, we're going to get 0.27. Okay, now we're going to go do area 2, earning less than 3,200. And so that's going to be 460 people out of a total of 814. Oh, that's going to be quite a high percentage, or a high decimal. And so that's going to give us 0.56. Well, let's just say 0.5. Yeah, I'll just say 0.56. Okay, so which is more likely? It's definitely going to be a person from area 2. Therefore, more likely from area 2.